Namaste dear students, this is your Srinivas sir and you are watching Sri9 Teaching YouTube channel. Now in this video I am going to discuss the physical sciences important questions from the second chapter, that is chemical equations, for the SSC examinations 2022. That is most important questions as well as concepts and objectives, whatever are needed for you for the examinations, I am going to give you in this video. At the same time, in the previous video I explained the important concepts and question answers, objectives of the physical sciences in the first chapter, that is reflection of light at curved surfaces. I hope you understood and it is useful to you, isn't it? Okay. And those the students, those who couldn't see the previous video, that is important questions and answers, concepts for the SSC examinations 2022, please watch. And here in this video I am going to give the link of the first video of the physical sciences. In the description I am going to give you the link, so those who couldn't see, please watch and understand. If you have any doubts, you can comment in the comment section, so I will give you the answers. Okay, now let us start the second chapter of the physical sciences, chemical equations, the important concepts and question answers. Okay, so before that, please like my video and share it to your friends. Please subscribe my channel for the further videos. Okay, now let us start the chemical equations. Yes, dear students, so this is the second chapter, chemical equations. In the first one, now what is the heading here? Chemical equation. Now before that, I'll explain what is chemical change. Here, any two new substances combine to form a new substance. Any two or more substances combine to give a new substance which is different from the previous substances is called a chemical change, which cannot be reversed to form the original substances. Okay, that is chemical change. For example, if you rub a matchstick on the side of the matchbox, it will burn, isn't it? Again, you will not get the matchstick unburnt, right? So that is. And another example, if milk is converted into curd, again we cannot get milk from the curd. So that is a chemical change. Because of lactobacillus bacteria, the milk is converted into curd. So, and another example, if magnesium ribbon or magnesium metal is burnt in the presence of oxygen, it burns by giving a bright light and it forms ash, that is grayish ash, called magnesium oxide. So as magnesium burnt and gives magnesium oxide, from the magnesium oxide we cannot get magnesium metal again. So all these are examples for chemical changes, and these chemical changes or the chemical reaction, we say, can be expressed in the form of equation, which is called a chemical equation. Now the definition you see on the screen: a chemical equation, a chemical reaction expressed in terms of formulae and symbols is called chemical equation. Okay, a chemical reaction which is expressed in terms of formulae and symbols is called chemical equation. Next, a chemical equation of a reaction is written in the form to show the change of reactants to products by an arrow placed between them. Here, in the chemical reaction, we write the formulae or the symbols of the substances which are undergoing a chemical change by placing plus in between them, and then we write arrow. The arrow shows as a chemical change is going on, and the right side of the arrow we write the formulae and symbols of the substances which are formed after chemical change or after chemical reaction. Okay, now you see the example, the reaction between calcium oxide and water can be written as word equation. You see, actual calcium oxide is also called quicklime. When it reacts with water, it produces heat as well as calcium hydroxide. So here the calcium oxide, water, in between a plus symbol is there. It means that these two are combining and here arrow shows that after combining what is going to form. So here what is formed? Calcium hydroxide is formed, and this is we wrote in the form of words. So hence it is called word equation, and instead of word we use the formulae or the formula. So the formula of calcium oxide is CaO, and the formula of water is H2O. So here CaO plus H2O combined together, and the arrow mark we read as gives rise to what? It gives rise to calcium hydroxide, CaOH twice. We read as CaOH twice. Now, so what is the use of writing like this? Yeah. So in sentences we say calcium oxide reacts with water and gives calcium hydroxide. Instead of saying this, we can easily write in the form of symbols and formulae, so that by seeing that equation we can easily understand what reaction is happened or what reaction is occurred, isn't it? So that is the usefulness of writing chemical equation. So we are writing an equation form of a chemical reaction, that you understand. So once again I am explaining the chemical equation. So here calcium oxide CaO plus H2O reacted and gives CaOH twice. So CaO is calcium oxide, H2O is water. The arrow shows we read as gives rise to CaOH twice is called calcium hydroxide. So this is an example of chemical equation. Okay, right. Now let us see the equation and interpret, or we explain the chemical equation. What information do we get from a chemical equation? You see, what information we get from the chemical equation means, here we get the substances which undergo chemical change in the reaction. So the substances which undergo chemical change in the reaction are called reactants. What do we say? These are reactants. Means in the above equation, calcium oxide and water combined, so and formed calcium hydroxide. So the substances which are undergone chemical change, yes, calcium oxide plus water. Hence we say calcium oxide and water are reactants. And what is formed? What the new substance formed? Calcium oxide. So the new substances formed are called products, and calcium hydroxide is called as product. You take any equation, for example, if zinc reacts with oxygen gives to zinc oxide. So in this equation, which are reactants? Zinc and oxygen. And what is formed? Zinc oxide, that we say that is as a product. Okay, now next see the next point. In the above equation, calcium oxide and water are reactants and calcium hydroxide is product, as I said. Okay, now next, change of reactants to products is shown by an arrow placed between them. In the equation we write as the symbols of the substances which are undergoing chemical equation by placing plus between them, and we write arrow mark. It shows that the chemical reaction is occurring or happening. Next, what does arrow mark shows? The arrow head point faces the products, showing the direction of the reaction. We keep right side, means left side reactants are combining or they are undergoing a chemical change, and it is giving a product which we write on the right side of the arrow mark. Okay, right. Now next point, the reactants are written on the left side of the arrow and the products are on the right side or head of it. So reactants are written on the left hand side or left side, and the products are on the right side. Where? In the chemical equation. Now let us see some more chemical equations here. So first equation, zinc, Zn zinc plus 2HCl gives rise to ZnCl2 plus H2. See here, once again I am reading for you. Zn plus 2HCl. Here Zn is nothing but zinc, HCl is nothing but hydrochloric acid, and arrow mark is there. It shows the chemical change has occurred, and what is formed? ZnCl2. ZnCl2 is the formula for zinc chloride and also hydrogen gas. Now let us see the second equation. 2H2 plus O2 gives rise to 2H2O. So in the above reaction and in this reaction, the substances which are written on the left side of the arrow, back side of the arrow, are called reactants, and the right side of the arrow are called products. Okay, and the third equation you see, Fe2O3 S means solid plus 2Al aluminum, S means solid, in the brackets S is there, S is nothing but solid, and gives rise to 2Fe, S solid, Al2O3 solid. So the names Fe2O3 is ferric oxide, 2Al that is aluminum, 2Fe that is iron, and Al2O3 is nothing but aluminum trioxide. Okay, so now this is the writing of a chemical equation. What is the chemical equation and how to write, just we have seen. Now next, now let us see on the screen second one, balanced chemical equation. We have seen what is chemical equation, and next the new word came, balanced. Now let us see what is the meaning of balanced chemical equation. See here, a rule is there. According to the law of conservation of mass, according to the law of conservation of mass, you have learnt in 9th class, it is in a chemical reaction, mass is neither created nor destroyed. Once again I am reading. According to the law of conservation of mass, in a reaction, in a chemical reaction, mass is neither created nor destroyed. In other words, in a chemical reaction, the total mass of the products formed must be equal to the total mass of reactants consumed. It means that just before we have seen here in the above three equations. So in the above equations, whatever the substances are combining or participating in a chemical reaction, here their mass is equals to the mass of the newly formed products that are right side. So we have seen that left side substances are called reactants and the right side substances are called products. So here the right side of the arrow, whatever the products are there, their weight, the mass of them is equals to the mass of the reactants, which are written on the left hand side. So this is called balanced chemical equation. Okay, according to the law of conservation of mass, the mass of the reactants should be equal to the mass of the products. Okay, right. Now here, an atom is smallest particle of an element that takes part in a chemical reaction. It is the atom which accounts for the mass of any substance. Okay, so in a chemical reaction, the mass of the products on the right side should be equal to the mass of the reactants on the left side. So there we take number of atoms, because atom is the smallest particle, from which we continue to write the mass of the left hand side substances should be equal to the mass of the right hand side substances in the form of atoms or formulae. Okay, now next second point, the number of atoms of each element before and after the reaction must be the same. Okay, before reaction the number of atoms, and after the reaction number of atoms on the right hand side should be same, then it is called balanced equation. Third point you see on the screen, a chemical equation in which the number of atoms of different elements on the reactant side, that is left side of the arrow mark, whatever the reactants are participating, their number of atoms is as same as those on product side is called a balanced chemical equation. This is the correct definition of balanced chemical equation. Last point, balancing a chemical equation involves finding out how many formula units of each substance take part in the reaction. From the chemical equation we will understand that how many formula units, whether one formula unit of water or one formula unit of hydrogen is reacting with one formula unit of oxygen to give rise to water. Like that we understand how many formula units. But you may get that what is formula unit. Let us see here. Now we are seeing and understanding what is formula unit. So here formula unit is one unit of atom or ion or molecule corresponding to a given formula. See example, formula unit of sodium chloride NaCl is one Na plus ion and one Cl minus ion. So Na plus is one formula unit and Cl minus is another one formula unit. Okay, now second example B, you see formula unit of magnesium bromide MgBr2 is 1 Mg plus 2 ion and 2 Br minus ions, because MgBr2. So what are the formula units of MgBr2 means one is Mg plus 2 and another is 2 Br minus ions. Okay, right. Now steps to write balanced equations. Now how to balance a given chemical equation. This is very important. Definitely in public examinations the questions will be given from the chemical equations, especially to it will be asked balance the following chemical equations. In this video I am going to explain clearly how to balance the chemical equations. Okay. Now let us read for the steps. Steps to write balanced chemical equations. Let us consider chemical reaction of hydrogen with oxygen to form water. You know that hydrogen combines with oxygen and forms water. In that one, how to write the steps in a chemical balanced equation. Okay, step 1. You see, step 1, write the equation with the correct formula for each reactant and product. Okay, whatever the reaction is going on or taking place, first we should write correct formula for each substance on the left hand side as well as on the right hand side. Okay, now see, first, what is primary equation? Now see, chemical equation which has only molecular formulae of the substance and not got balanced is called primary equation. Okay, so primary equation means here whatever the formulae of the substance are there of reactant side as well as product side which is not balanced. Which is not balanced means number of atoms or molecules on the left hand side is not equal to number of atoms or molecular formula on the right hand side. It is called non-balanced, whether it is primary equation. Okay, now how to identify suitable coefficient? Step 2, identify the suitable coefficient. Whole number. Okay, once you see the primary equation of water, H2 plus O2 gives rise to H2O. Okay, this is primary equation. Now we have to, whether it is balanced or not or how to balance, let us see in the second step. First, whole number written before formula for balancing chemical equation is called coefficient. Now coefficient indicates number of formula units required to balance the equation. Okay, now during balancing a chemical equation, only coefficient should be changed but not the formulae. We will not change the formulae or subscripts or superscript. The numbers which are written bottom are called subscript. The number which are written on the powers are called superscript. Here we will have only subscripts. So we should not change the subscripts. So only we have to write any number left side of the formula unit which indicates it is to be balanced. Okay, or it is balanced. You see, third point, to balance this equation, coefficient 2 is written before H2O and H2. You see, previously it was H2 plus O2 gives to H2O. Now you see, here on the left hand side 2H2, it is nothing but 2 to the 4 H's. Right side of the arrow you see 2H2O. 2H2O means 2 H2s and 2 O's. So 2H2 means 2 to the 4. So on the left hand and right side 4 H's are balanced. So here left hand side 2 H2s and here also 2 H2s. And O2 is there but here 1 O is there. But as 2 is written here, it is nothing but 2 O's. Got it? It is not 20, it is 2 O's. Yes, so it means that 2H2 plus O2 gives rise to 2H2O. Now it is balanced. Step 3, after balancing, coefficient should be the smallest possible whole numbers. If necessary, divide all the coefficients with the same number to get the smallest number possible. On either side, if 2 are there equally, we can divide by 2. If 3 are there at all the substances, not one or the other. Okay, right. Now second point in the step 3. In the above equation, coefficients of reactants and products are the smallest whole numbers. Therefore, it does not require any division. Okay? Yes, because 2 is the very small, hence we cannot divide it by anything. And especially beside the O2, there is no coefficient. Hence, we cannot divide the 2 on either side, left hand side or right hand side, because O2 has no coefficient. If it has 2, then all the 2's are divided by 2. We would have got H2 plus O2 plus H2O like that. Okay, right. Now let us see the fourth step. Verify the equation for balancing of atoms on both the sides of the equation. After writing the coefficient, we have to check on the left hand side as well as right hand side. The number of related atoms on the left hand side should be equal to the number of atoms on the right hand side. If it is so, then we say the chemical equation is balanced. Got it? Yes, in the equation 4 atoms of hydrogen and 2 atoms of oxygen are the same on both sides of arrow mark. So on the left hand side 4 H's are there and right side 4 H's are there. Left side 2 O's are there, right side also 2 O's are there. If coefficient is written is nothing but it indicates the number of atoms in the whole formula. Remember. Now next, making chemical equations more informative. Chemical equations can be made more informative by expressing physical state, heat evolved, pressure, etc. Now what is physical state? The physical state of the substances must be mentioned along with their physical formulae. Here S means solid, L means liquid, AQ means aqueous, and G means gas. Okay. Now let us see example Fe2O3. So in brackets S is there. It means that this is solid, plus 2Al. In brackets S is there. S means solid. Gives rise to 2Fe. S means solids, plus Al2O3. S means solid, like that. In the same equation we are writing in brackets whether it is solid means S, whether it is liquid means L, whether it is aqueous means we write AQ. Okay. Now see the second equation, Na2SO4. It is aqueous, means solid Na2SO4 is dissolved in water. Now it is aqueous solution. Okay. Plus BaCl2 AQ in brackets. It means that it is also same, dissolved in water. Now when they combine, it gives rise to BaSO4 S. S means solid. Okay. Plus 2NaCl AQ. AQ means aqueous. Now the C equation, zinc solid S plus H2SO4. L means liquid, gives rise to ZnSO4. It is liquid plus H2. G. See, H2G means it is gas. Now in brackets S solid, L liquid, G gas, AQ means aqueous. Substance is present as solution in water. So like this we make the equations more informative by writing their physical states, whether it is solid, liquid, aqueous or gas, like this. Got it? Now let us see the heat changes or the reactions depending on the heat changes. Here let us see what is heat changes. Now see, heat is liberated in a exothermic reaction and heat is absorbed in endothermic reactions. So there are two types of reactions. One is exothermic and another is endothermic. So here see the example, C plus O2 gives rise to CO2 plus Q. Here plus Q means heat is liberated. So hence this reaction is called exothermic reaction. Here in this equation, C in brackets S means solid and O2 G means gas, gives rise to CO2 which is a gas plus Q. So we write plus Q on the product side when heat is liberated. Now in this reaction, as heat is liberated, this reaction is called exothermic reaction. Now let us see the example B. Here N2 gas plus O2 gas gives rise to 2NO which is gas, and here just see minus Q. So whenever we write minus Q on the right hand side of the arrow mark or on the product side, it is nothing but heat is absorbed. If you write plus Q, heat is liberated, and if you write minus Q, it is nothing but heat is absorbed. So here clearly written that Q is heat energy which is shown with the plus sign on product side for exothermic reactions and minus sign on product side for endothermic reactions. Okay. Yeah, so these are the reactions depending on the heat, whether heat is released or heat is absorbed. Now let us see if gas is evolved. See, gas evolved if any. If a gas is evolved in a reaction, it is denoted by an upward arrow. So see the example, Zn solid plus H2SO4 which is L liquid gives rise to ZnSO4 zinc sulfate. H2G is nothing but gas plus Q. So Q means heat is liberated as well as hydrogen gas is liberated. So concentrate plus Q is written. It is nothing but heat is also liberated. Hence it is exothermic reaction. But you concentrate here, the arrow mark is written, okay, upward. It is nothing but it is a gas. Now which gas? H2 gas. Okay, this is first example. Now concentrate on second example. C, carbon solid plus O2 gas. It is nothing but carbon is burnt in presence of oxygen and carbon dioxide is liberated. See here arrow mark is written in upward direction. It is nothing but CO2 is a gas. So plus Q means heat is liberated. So from this concept we understand that in a reaction, if gas is liberated, then we denote it or we write arrow mark upwards to show that the gas is liberated. Got it? Right. Now precipitate formed if any. Next subheading, precipitation or precipitate formed if any. Then how to write in the equation. See here, if a precipitate is formed. What is precipitate? A solid substance which is remained or retained at the bottom of the vessel or test tube or a beaker without dissolution. It is nothing but in a solution, if a substance is not dissolved, it is collected at the bottom, which is called precipitation. Okay. Now, if a precipitate is formed in the reaction, it is denoted by downward arrow. Got it? Now, let us see the example here. AgNO3, which is aqueous, that is solution, silver nitrate solution. NaCl, sodium chloride solution. So when they mixed, it gives rise to a solid substance which is called AgCl. S means solid, which is collected at the bottom. AgCl means silver chloride. It is a precipitation, hence the arrow mark is written in downward direction. And NaNO3, which is in the form of liquid. Okay, that is AQ means aqueous. Now this is the first example. Now let us see the second example. That is Na2SO4, sodium sulfate, which is aqueous solution, plus BaCl2, that is barium chloride. When they mixed, they give rise to BaSO4, barium sulfate, which is denoted downward arrow mark. It is nothing but it is also a precipitation, and plus NaCl, which is aqueous. Okay, so in the both examples here we have seen that downward arrow is there. It is nothing but it denotes that a precipitation is formed in this reaction. Got it? Yes. Now see on the screen here, temperature, pressure or catalyst etc. is usually written over or below the arrow in the equation. Okay, if temperature is involved or pressure is involved or catalyst is, it is nothing but catalyst is a reagent or a substance which increases or decreases the rate of reaction of a chemical change. Okay, so here when they are used, they are written at the arrow mark. See the example, 2AgCl, silver chloride, gives rise to sunlight. So sunlight means it is written on the arrow, it is nothing but this reaction taking place in sunlight, and it gives 2Ag plus Cl2, silver plus chlorine. Both are formed in the presence of sunlight. So when heat is evolved, we write heat or delta sign we write on the arrow, or if it is the catalyst is used, we write the catalyst on the arrow. So it denotes that such things are involved, right? Now this is one type of chemical equation we use. Now coming to interpreting a balanced chemical equation. Okay, now this is the last topic here. See, chemical equations give information about first reactants and products in the reaction. That's the first point. Second, ratio of molecules of reactants and products. Ratio of molecule means on the reactant sides as well as on the product sides, how many molecules are involved in a reactants and how many molecules are formed on the product side. That is second point. And third, atomic masses of reactants and products. We can also denote or we can also find, or a chemical reaction gives about the atomic masses of reactants as well as products. Now see the fourth point, molar mass of reactants and products. Fifth, relative masses and mole number of the reactants and products. So this is the last topic. Actually here the fourth and fifth point involves problem solving in a chemical reactions. I will explain the problem solving of chemical equations in the next video. So before that, here I am going to show how to balance the chemical equations with examples. Okay, and also from the questions given at the end of the lesson, from that I am taking some chemical equations and I will show you how to balance the chemical equations, because the balancing of chemical equations definitely will be given in the final examinations. So be careful about that. You must learn how to balance the chemical equations compulsorily, right? Now let us see how to balance chemical equations by taking examples. Okay.